Okay, one more video here to close out this worksheet here. Sorry about this, it's a little messy over here. That was the derivation of the kinetic energy formula, which is right here. Determine the kinetic energy of a 15 kilogram object moving at these two speeds. So this is just practicing using this equation, right? So we're doubling the speed. We'll see what effect that has on the kinetic energy. So KE equals 1/2 mv squared. So that's 1/2 of 15 kilograms times 10 meters per second squared. So you gotta be careful here. You can't forget to square that speed. So 10 squared is 100, right? Times 15 times 0.5. I'll move this over to see my calculator. I got 750. And what are the units on that? It's joules. It's energy. All right, so if we double the velocity, will that double the energy? Well, not quite. We'll see. So the kinetic energy now is 1/2 of 15 kilograms times 20 meters per second. The whole thing squared. So 20 squared is 400. So that's quite a bit bigger. That's 4 times bigger. 0.5 times 15 times 20 squared is 3,000 joules. So by doubling the velocity, we actually quadruple the kinetic energy because it's squared. So you're doubling something that's going to get squared, so the effect is squared as well. So 2 squared is 4, so it's 4 times bigger kinetic energy. Now, if you were to double the mass, let's say you made this 30 kilograms, you'd get roughly 1,500 joules, right? Because you would double the mass, you would double the amount of kinetic energy the object has. So that's just a little practice using kinetic energy formula. All right, so let's see what we have next here. Okay, work and changing kinetic energy. So remember, work net equals change in kinetic energy, which equals F net times displacement. All right, oops, wrote that off the screen. Sorry about that. A force does 10,000 joules worth of work to get 10 kilograms object, to get a 10 kilogram object up to its max speed. Determine the top speed of the object. All right, so work equals change in kinetic energy. Change in kinetic energy. That's going to be kinetic energy final minus kinetic energy initial. All right, your kinetic energy initial is 0 because this object's going to start at rest, right? It's going to start at rest, so your initial kinetic energy is 0. So the work done is going to be equal to the amount of kinetic energy you gain. It's going to be equal to the final kinetic energy. So 10,000 joules of work equals, and it's positive here. It has to be positive because the object starts at rest. You can't have negative work if something starts at rest. What would happen to it? Well, it can't change anything. Maybe it could change potential energy, but it can't change kinetic energy if it's negative work being done. All right, so, well, I shouldn't say that. If it starts at rest. The final kinetic energy is 1/2 mass times V final squared. So 1/2 of 10 kilograms times V final squared. So now that's our unknown, the V final. So we have to solve for that. So we multiply both sides by 2. Bam, bam. Then we divide both sides by 10. And we end up with V final squared equals 2 times 10,000 divided by 10, which equals 2,000. Now, what are the units? I don't know. I mean, I do know, but it's joules per kilogram. You have to take the square root of both sides to get the final correct answer. So V final equals square root of 2,000. Square root of 2,000, which is about 45 meters per second. All right, so don't forget to take the square root of both sides. So 10,000 equals that. you go through and solve it. All right. This one here, I'm not going to do the whole thing right now. I want you to try to do that one, but I will talk a little bit about it. It rolls down a hill and gains 100 joules of Ke from work done by gravity. It reaches a speed of 12 meters per second. Determine the skateboard's mass. All right, so in this case, work equals change in kinetic energy. All right, so that's going to be equal to, it's gaining 100 joules. So 100 joules equals 1/2 mv final squared. So for this one, you know V final, so plug that in and solve for mass. Don't forget to square V final when you do that though. All right, you got to solve for mass. I'm not going to finish that right now for you. You can do that on your own and then check back with the solutions later. I will do one of these though. I'll show you this here. So person does 400 joules of work on a 6 kilogram object, while friction does negative 200 joules of work. The object started at rest. Determine its final speed. All right, so the equation is work net equals change in kinetic energy. So work net, it's the sum of all the works being done. So while the person is doing 400 joules of work, that all doesn't go into increasing the kinetic energy because friction is taking away 200 joules of work. Work net here, it's plus 400 joules plus negative 200 joules. So work net is positive 200 joules. And that's going to equal 1/2 mv final squared. So again, you're going to be solving for the final velocity here. So it's the same procedure as number 8. Multiply both sides by 2, divide both sides by the mass, take the square root, you get the V final. So you have to solve for the V final on that one. Again, I'd like you to try to do that. This one's kind of an interesting one, and this one's a little bit different. This is an object initially is moving upwards with a speed of 15 meters per second. All right? And its mass is 4 kilograms. So what's the initial kinetic energy? Let's figure that out first. 1/2 mv squared. Now here's the trick. As it goes up, it's slowing down, right? So as it goes up, Ke goes down. And Peg goes up. Right? So we're converting from kinetic into gravitational as it goes down. So it's slowing down. So Ke goes down. It's losing 400 joules of kinetic energy. So what you got to do here is figure out the initial kinetic energy. 1/2 mv initial squared. All right, that's going to be some number, 0.5 times 4 times 15 squared. About 450 joules is the initial kinetic energy. So here's the deal. Work equals change in kinetic energy. The work here is negative 400 joules. Ke final minus Ke initial, right? You don't know what the Ke final is. That's what you need to find. You need to find that final kinetic energy so you can find the final velocity. Minus the initial kinetic energy, which is 450 joules. So your final kinetic energy is going to be 50 joules because you started with 450. Gravity took out 400 as it was going up. So you're only going to have 50 left over. Well, set that equal to 1/2 mv final squared and solve for V final squared. Again, I'd like you to try to finish that math on your own. So you might have to watch this a couple times, go through it slowly, get the framework filled out, try to finish out the math. At the end of the day, the net work equals the change in kinetic energy, which equals Ke final minus Ke initial. Ke equals 1/2 mv squared. So give it a shot. We'll see where we're at, see how it goes. We'll go through it pretty slowly in class.